In my previous videos, I've showed you guys that how to come up with a formula for the sequence 0, 1, 0, 1, 0, 1, 0, 1, and so on, right? And one of the answers I gave you was this, the absolute value of cosine of pi over 2 times n. And I also talked about how to come up with a formula for the sequence 0, 0, 1, 0, 0, 1, and so on, right? And the answer I gave you guys was that 1 plus 2 times cosine of 2 pi over 3 times n all over 3. And if you haven't seen the videos for these two sequences, you can find the links. They are in the descriptions. All right. Today, why don't we talk about how to come with a formula for the sequence 0, 0, 0, 1, 0, 0, 0, 1, and so on. What formula can we come up with? All right. Well, as I mentioned it before, we should use sine cosine because we're dealing with a repeating pattern. So sine cosine should help. And of course, we are not doing the percentage symbol for mod, all right? So let's get that out of the way because this is the math video. So yeah, no offense to the computer science students. Strictly just sine, cosine, tangent, whatever. Anyway, another thing I want to tell you guys is that our convention is let n start at 1, okay? Sometimes you can define to let n start at 0, but let's just say n is equal to 1 to begin with. Okay, enough talking. Here is the deal. Let's once again look at the unit circle. And you see, we are looking at a block of 4 things, right? 0, 0, 0, 1. And then the next one is once again 0, 0, 0, 1, and so on, right? It's like a copy of a block of 4 things every single time. Therefore, I'm going to cut this unit circle into 4 pieces. But instead of cutting it vertically and horizontally, which we did that for 0, 1, 0, 1, I'm not going to do that again. I will actually cut this into 4 pieces the following way, which is going to be like this, right? So I'll cut it like this and like that. And the reason is because if I cut it horizontally and vertically, I know I will end up with 0, 1, 0, 1, just like what we did last time already. So I want to avoid that. And when I cut this right here, of course, let's talk about the values of the, let's use cosine because I gave you cosine, cosine. Let's talk about cosine. So let's talk about the x value of this point, which is cosine of pi over 4, which is, we know right here, 1 over square root of 2, comma, something, which doesn't matter. And you know it's 1 over square root of 2 as well, but doesn't matter. So cosine of this point right here is 1 over square root of 2, right? And of course, we don't need to rationalize the denominator because we're all adults now, right? All right, so if you go to the other side, which is right here, this is negative 1 over square root of 2, comma, doesn't matter. And this right here is also negative x value, negative 1 over square root of 2, doesn't matter. And then this right here is positive 1 over square root of 2, comma, doesn't matter. All right? So we are looking at this for the cosine values. Okay, if you observe this carefully, we have 1 over square root of 2, and then negative 1 over square root of 2, and then negative 1 over square root of 2, and then positive 1 over square root of 2. If you look at it from the first quadrant, second quadrant, third quadrant, and fourth quadrant, like that. I don't think that's helpful because, well, the pattern just doesn't seem right for some reason. If you look at it this way, 1 over square root of 2, 1 over square root of 2, negative 1 over square root of 2, negative 1 over square root of 2. It's like a block of 2 things every single time. It's like AA, BB, AA, BB, so on, so on, so on. Rather than saying A, B, B, A, and then so on. That doesn't really help, in my opinion. But anyway, so let me just write down some formula and then see what kind of numbers that it's going to produce for us. And as I said, I want to start at this point. Namely, from here to here, it's going to be negative pi over 4, okay? This is the 45 degree down below. Okay, so I want to start off, and we'll just write it down here. Cosine of negative pi over 4. This is going to be right here, all right? And let's see what can we get. I want to end up with 1 over square root of 2, and then I want to get to the next one. And when I get to the next one, you see, I actually have to go from here, and then I have to add 90 degrees, namely pi over 2. So inside here, I'm going to say I will add pi over 2. And every single time when you want to get to the next place, you add another pi over 2, right? So I will have to multiply this by n, but n starts at 1. So if you have this as how it is, then you will have negative pi over 4 plus pi over 2 times 1. And you actually are talking about starting right here. You don't want this to be appearing at the first place, right? Therefore, instead of n, we will need to have n minus 1. Because once again, n starts at 1, all right? So when n is equal to 1, 1 minus 1 is 0. So this doesn't matter. We are starting at cosine of negative pi over 4. And we get our 1 over square root of 2. Anyway, once you keep plugging the n values, you get to the next point and next point. So you get to have 1 over square root of 2. And then the next one is the negative version now, negative 1 over square root of 2. And then negative 1 over square root of 2. And it's going to come back here. So I'll just write it down, 1 over square root. So this is that. Well, we don't like this neither because, of course, this is a bunch of square root of 2 in the denominator. We just don't like it. Therefore, why don't we multiply this formula by square root of 2 so that we can multiply every term by square root of 2 like this, right? So when you do this times this, you just get 1, 1, negative 1, negative 1, 1, 1, negative 1, and so on, all right? All right, now, I want to end up with this, though. 0, 0, 0, 1, 0, 0, 0, 1. Okay, how can we do this, though? I want to have a lot of zeros rather than 1, 1, negative 1, negative 1, and so on. Why don't I try to produce some zeros at first, and then some whatever later on, and let's see what we can do, all right? Okay, based on this, we have 1, 1 already to begin with. I don't want the 1, 1. I want 0, 0 maybe. Therefore, I will go ahead and say, let me just multiply this by negative 1. So you're talking about negative 1, negative 1. And then I will add 1 to it so that 1 minus 1, 1 minus 1 will be 0, 0, all right? Okay, so this is what's happening. Let me rewrite it again for you guys. If you have the sequence formula, which is 1 minus square root of 2 times cosine, and of course, we can do some small algebra here. You distribute, pi over 2 times n, that's just pi over 2n. And this is negative pi over 4, and this is pi over 2 times negative 1. In another word, negative pi over 4 minus pi over 2. Altogether, we get minus 3 pi over 4, right? Just simplify that, right? This is going to give you, as I said, you multiply every term by negative square root of 2 technically, and you add 1 to it. You actually end up with 0, 0, and then what's next? Well, do this real quick. Negative square root of 2 times this, it's going to be positive 1, right? This times this is positive 1. And then you add 1 to it, so you get 2 and 2, and so on. So you have 0, 0, 2, 2, and then, of course, 0, 0, 2, 2, and so on, okay? And now, of course, we can just divide everything by 2, just like how we did the second one last time. So that means we divide everything by 2. So we get 0, 0, 1, 1, 0, 0, 1, 1, and so on, so on, so on. All right, we have 0, 0, 1, 1. I want to end up with 0, 0, 0, 1. If you would like, let's just write this down again. So, okay, so this is what we have. And this is what we did last time. And this is what we want. The first two 0 match. That's great. But I want to kill this one, right? I want to kill this one. You may be thinking, can we just subtract this sequence? So you see, if we just do minus 0, minus 0, minus 1, okay, we get 0, 0, 0, 1, right? Because next is minus 0 and then minus 0 again. So far, so good. But the issue is that I will have to minus this 1 with this 0. 0 minus 1 is negative 1, which is not the same anymore, unfortunately. Therefore, this right here is not what we want, all right? we actually cannot utilize the second sequence to help us out. But rather, let's look back to the first one. Let me just write this down for you guys. What if I put this down in blue? We have 0, 1, 0. This is our goal. Let me write it down. The goal is 0, 0, 0, 1, 1, 0. And so on, so on, so on, forever. How can we produce this right here? Well, look at. If you do 0 plus 0, that's 0. But unfortunately, 0 plus 1 is 1. I want to have 0. However, if you look at multiplication, check this out. 0 times 0 is equal to 0. 0 times 1 is equal to 0. 1 times 0 is equal to 0. 1 times 1 is still equal to 1. And likewise, this is going to work for the rest as well. Therefore, in order for you to come with this formula, to come with this sequence, all we have to do is take this formula in black times this formula in blue, and we will be done. All right? So all I need to do is just multiply this and that together. And lastly, I will just write this down so we can be legitimate and we can all go home happy. This is going to be 1 minus n absolute value. And this will produce this sequence for you guys. All right? So here is the answer. And we did not use the percentage symbol, namely the modular arithmetic, namely the computer science language. Anyway, that's it. Hopefully, you guys like it.
As you know, Versailles is the home of King Louis XIV of France. These gardens had many love affairs. They also show that he is the Sun King, and that anybody who betrays him will end up dead.